Hi, I decided to make this experimental video explaining my clock tower creation made of Infento. I hope you stay with me till the end. The clock tower is made almost exclusively from Infento components, with only a few exceptions which I will explain through the video. I use Infento version 1.0 because I bought the first Genius set already in 2019 and I extended it by many extra parts since then. So let's jump into the functions. Clock needs energy to run. I could have used Infant electrical motor, but that would have ruined the beauty of replica of an old mechanical clock. I got 20 kg weight, which can be lifted about 40 centimeters above the ground. The heavier the weight, the slower it can be lowered to produce the same mechanical work. I use pulleys to trade pulling force for longer run. The pulleys are 3D printed and I presented them already in several previous projects. After many tests, I set the pulley reduction ratio to 1:4, which means that the acting rope pulls with 5 kg or 50 newtons of force over a distance of about 160 centimeters. The most force I needed was obviously to overcome friction in the system. And with 25 gears, 2 tooth belts and 17 active bearings, the clock has plenty of friction. To be able to wind the clock, so to lift the weight, I needed to add a ratchet mechanism. For that I use Infento freewheel, which can freely spin in one direction but locks in opposite. Another component mechanical clocks usually have is some kind of escapement mechanism to generate the ticks. After some reading, I decided for verge escapement with foliot. Verge, also called crown wheel, is here created using Infento flange with bolts, and foliot is this horizontal oscillating bar. The benefit compared to verge escapement with pendulum I used before is that it can generate slow movement in more compact form. As you can see, one tick-tock cycle is about 2 seconds. Pendulum with the same period would have to be about 1 meter high. The speed is adjustable using the weight and position of these 7-inch wheels mounted on foliot. More weight and further from center, more inertia the system has and slower it accelerates when the same momentum is applied. The important bit is of course this verge or crown wheel. In half of the period it accelerates the foliot in one direction until it slips and then the opposite tooth takes over to stop and accelerate the foliot in opposite direction, and so on. On Wikipedia you can read that the verge escapement with foliot is the oldest known type of mechanical escapement used for timekeeping, dating back to 13th century. The crown wheel gets its energy from the weight via this 3D printed 13 teeth gear. I could have used original 26 teeth gear, but I wanted to get more tick-tock periods per weight movement. In this configuration, the total runtime is about 10 minutes before the weight gets on the ground. So, with energy source and escapement mechanism, we have a good basics for a clock. The most important aspect of this project was for me to create functioning 4-phase clock tower. This is actually how I started the project. Just playing with 2 standard Infento gears in CAD and trying to get this mechanism to work. I recently figured out that I can use the gears as a bevel gears attached under angle. And from my previous clock creation, I knew that I have to use freewheels to be able to put minute and hour hand on one axis. If you didn't see that one, please check that video. If you got so far here, I think you will like it as well. So I started just with the basic idea I had in my head, but in this configuration the gears could not move, they were interlocking each other. The eureka moment came when I figured out how to drive both hour and minute hand on all 4 faces without gears colliding. The important bit is that the horizontal bevel gear must be larger than the vertical ones to prevent locking. That was easily done for the minute hand, but for the hour hand I had to add 4 intermediate gears to create the necessary space. And where 2 gears are on one axis, I use freewheeled in correct orientation to allow independent rotation. Fortunately, clock needs to run only in one direction. The minute hands are driven by the center axis and the hour hand by the other one. And they are linked at the bottom by belt system with other gears to create proper hour-to-minute movement ratio, which I will try to explain next. So, sure you know that the minute hand needs to rotate 12 times for one revolution of our hand. But looking at the original Infento gears, we have only 26 and 46 Ts. That means that with one gear set, I can only create a ratio of about 1 to 1.77. Using only these gears, I could stack 4 of them to have 1 to 9.8 ratio or 5 of them to get 1 to 17 ratio. Both solutions are not optimal and visually probably very noticeable. Fortunately, I had around some custom 3D printed 13 and 52 teeth gears from previous projects. So with one 13 to 52 and two 26-46 gear sets, I was able to create approximately 1 to 12.5 hour to minute hand movement. It's still not perfect, but now more convincing. The good news is that the two 26-46 reductions are already in the top of the clock tower. So my job was only to link the two axes together with 13 to 52 gears and a belt. After fiddling around with different configurations, I settled to use another two 13 teeth gears and link everything with two 100 teeth belts. I tried to use the original gears, but I didn't like the result. Joining an axis was always oriented somewhere awkwardly. The next step was to combine the clock tower with the clock mechanism in a neat and relative compact form. In normal clock, the minute and hour hands are made as light as possible to reduce disbalance of mass. I wanted to use Infento axes because I think they give the nice look to the clock, but their weight is not insignificant, especially when there are 4 of them. I was considering to 3D print lighter hands, but then I decided to add a balance weight which counteracts the mass imbalance. A bit of mass tuning and now the movement is smooth. Our hands are much lighter and rotate much slower, so I didn't need to compensate for them. In the way how I made a crank to wind the clock, I needed to add two freewheels. One to decouple clock movement and the second to decouple the escapement mechanism from the drum during winding. This also allows to adjust the clock when moving the hand in clockwise direction. And that's basically for the clock. But then I was thinking, what would a clock tower be without the bells or chimes? I don't have any bells I could use, but from my previous projects I had a little experience with making chimes using Infento Access. My goal was to create a simple two-tone melody. After some testing I settled for the double-tone chime. Chime has its own energy source in form of a smaller 3.5 kg weight. Pulley system with 1 to 4 ratio is again used to trade the pull force for longer run. And freewheel allows to wind its drum without movement of the rest of the mechanism. The crank again neatly detaches when the winding is done to prevent mass disbalance. Triggering of the chime is quite obvious, but required a bit of trial and error to get it working. I use a bolt in a proper place on the hour gear, which pushes Infento brake lever. Bowden cable then translates the movement to pull this pin and the chime starts. So this is it. I hope you enjoyed the explanation and maybe you learned something new. I really appreciate if you watched till here. Maybe now you want to check some other of my videos. Please subscribe and comment down below, then I will know that it makes sense to make these videos in the future. See you!